All right, today we will be dealing with systems of linear inequalities. So, just to review, systems of linear equations. We use the word system because we have more than one. And so, if we looked at this system of linear equations, we see that we have the two lines and they intersect at 2, 2. So let's talk about the equation of the line. So this equation, the slope of this line is up 2 over 1. So y is equal to 2x. Y-intercept is negative 2 minus 2. The slope of this line would be slope of the line is 1 over 1, so 1x, and then the y-intercept is 0, so y equals 1x. The place where they intersect would be 2, 2, which is the solution. Remember, the solution to the system is where the two lines intersect, or where the lines intersect. This is the point 2, 2, and we know that it's the solution because it satisfies both equations. If I put in 2, 2, 2 is equal to 1 times 2, which is 2. So 2 is equal to 2, true statement. 2 is equal to 2 times 2 is 4. 4 minus 2 is 2. Therefore, 2 is equal to 2. So it is a solution. Over here, we have a system of linear inequalities. So when we look at the first inequality, we see that the first line, call this the first line right here. The inequality is y is going to be, the shade is above the line, so it's greater than or equal to. The slope of the line is right here, up 1 to the left 1, so that's negative 1x or negative x. And the y-intercept is 0. So y is greater than or equal to negative x. And then this line right here, we have y, the shade is below the line, is less than, it's not equal to because it's not a solid line, less than, the y-intercept is at 2 right here. So let's find the slope. Up 2 over 1, so rising to the right, so 2x plus 2. So we have a system of linear inequalities. How is this similar to a system of linear equations? So if the solution is where the two lines intersect over here, what are the two things that are intersecting over here? Give you a moment. Dun 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 dun. All right. Well, two lines intersect. Two shaded regions. I knew y'all would get it. Where the two shaded regions intersect. This is where the solution is. What color is this? Let's pick blue, just something odd. All right. So this is where the two shaded regions intersect. So the solution is no longer just one number. It is any number in the shaded region, just like the solutions of a linear inequality, where any numbers or any ordered pairs in the shaded region. The solution will be any number in the shaded region. Now notice that we have a dashed line and a solid line. So we know that any point on the dashed line will work. Let's just make sure real quick. So this point, if I can get off the highlighter button. All right, I'm gonna use this point right here. So if I say, well, let's just use 0, 0. It's on the dash line. Just make our life easier. I'm gonna use black. 0, 0 on the dash line. So if I put in 0, 0, 0 is greater than or equal to 0. That's true. And then 0 down here is less than 2 times 0 is 0, 2. That's true. So you work. But on the dash line, if this is a slope up 2 over 1, if I use this point right here, 1, 1, 2, 3, 4, 1, 4, 1 is, well, 1, 4. 4 is greater than or equal to negative 1. That's true. But over here, we get 4 is less than 2x. 2 times 1 is 2. And 2 plus 2 is 4. 4 is less than 4. That's not true. So since this is not true, this is not a solution. So it works for one, but it doesn't work for the other. We know it works for one because this dot right here is in the orange shaded region. So it would work for this inequality, but it doesn't work for the dash region because this right here, yellow, you can't work on the line. All right, people, that's a quick lesson on linear inequalities before we move on. So again, the solution must satisfy both inequalities. It has to be in both regions. So when we get here, everybody, when we see a system of linear inequalities, we're asking, does 75 work as a solution? What will we be asking? We are really asking, is 75 in the shaded regions of y is greater than or equal to x minus 3 and y is greater than negative x plus 2? That's what I'm asking. Is 75 in the shaded region? Come on, connect with me, people. Don't just listen to me. Connect with me. Connect with what I'm just saying. So it's basically saying, is 75 in the shaded region? Of course, this is not the equation of those lines, inequality, sorry. That's what we're asking. So what do? We plug in. This is x, this is y. We plug them in. So we have 5, put the first one over here. 5 is greater than or equal to 7 minus 3. 5 is greater than or equal to 7 minus 3 is 4. That's true for that one, but we have to make sure it's true for both because we know it can work for one and not for the other. And then we have 5 is greater than, put in negative 7 plus 2. 5 is greater than, negative 7 plus 2 is negative 5. 5 is greater than negative 5. Yes. 75 is a solution. Beast mode, son. Get on my level. All right, so this is x, y. So we put in our y would be negative 4 is less than or equal to negative 2 times 8. Is that true? Negative 4 is less than or equal to negative 2 times 8 is negative 16. The larger the negative, the smaller the number. So the smaller the negative, the larger the number. That's not true. There's no need to check in another one if it doesn't work for one. Who cares if it works for the other? You have to work for both. All right, so you're going to do these two, pause the video, and do these two at the moment, and then bring it up to me when you're done. All right, so now we're going to graph the inequalities. The systems of linear inequalities that we're given is 3x plus 6y is less than or equal to 6, and y is greater than 2/3 x minus 1. So this is in standard form. Unless you know how to graph in standard form, use standard form. I'm going to use slope-intercept form because that's the method that doesn't matter what I ask y'all to do, use. That's, you're going to use that method anyway. So we have to get y alone. So for this one, we have to get y alone. So we have to do some work, people. 3x plus 6y is less than or equal to 6. If you want to know how to graph in standard form, you can come up and ask me. It will be a lot easier to graph in standard form. And so that's what I would do. 6y is less than negative 3x plus 6. Divide everything by 6, divide everything by 6, divide everything by 6. We get y is less than or equal to negative 3 over 6 is negative 1/2 x, and 6 divided by 6 is 1. So this is the first linear inequality. This is the second one. So we're going to graph this like we normally graph these. So we will start at, let's graph this one first. Start at 1, go down 1, to the right 2, down 1, to the right 2. Everybody, please remember negative slopes rise to the left. All right. So this is going to be a dashed, no, it's going to be a solid line. I'm going to cheat because my line is going to be a crappy if I don't do this. It's not really cheating. I'm just using technology. All right, so we have a solid line here. Where are we shading, everyone? We will shade less than goes below the line. We will shade below. And now we graph the next one. We have y is greater than 2/3 x minus 1, start at negative 1. And then go up to 1, 2, to the right 3, 1, 2, 3. Up 2, to the right 3. Down 2, to the left 3. Get a couple of dots up here. This is going to be a dashed line. So we will use dashes to shade. Whoa. All right. I don't know if y'all see that or not, but I'm going to act like y'all do. Dashed line. Where we shade, people, this is greater than, so we'll shade in the greater region. Y'all see what I did there? Y'all like that? Because you know, yellow and red make orange. Ha ha! You see these color change. Y'all see that? You see that? Yeah, that's great. That's great work. You know, that's what I do. All right. So the solution would be any order pair in the shaded region that can be on this line, but it can't be on this line. So give me 5 solutions. So 5 solutions. I'm gonna give you 2. You give me 3 more. I'm gonna say negative. What's this? Negative 4. Negative 4 1 would be a solution, and then 0 0 would be a solution. Yeah, I picked 0 0. You pick 3 more. Non-solutions could be in this region, could be in this region, or could be in this region because it has to be in both shaded regions. So a non-solution could be not on the line right there. You qualify. 2 1 is a non-solution. Put an X there, doesn't work. Check you work. And then I'm going to say 0 2 is a non-solution. You don't work. Okay, so give me 3 more solutions and 3 more non-solutions. All right. Hope y'all are getting this. And we will move on to the next slide. Okay, now we're going to look at graphing another one. I'm going to do one more. It says graph each system of linear inequalities. So both of these are in slope-intercept form. So I have y is less than 2x minus 1. So we have y here. The negative 1 is the y-intercept. So we have a negative 1 here. And then we go up 2 over 1, up 2 over 1, up 2 over 1. Put several dots here so we can see what this line is doing. And there is no equal to sign. So we have a dashed line, dash line. Please put arrows at the end of your lines. Less than, so I will shade to the bottom of the line. Shade, 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 shade. And then I have y is greater than 2. Please remember, everybody, this has a slope of 0. Starts at 2. Slope of 0. Horizontal line. Stop giving me y-axis. Please, just stop that. Stop doing that with your life. All right, so it is a horizontal line, and it's going to be dashed because it's not equal to. So we have a dashed line here. Put arrows at the end. It's a line, not a line segment or a dash segment. All right, so y is greater than. Greater than is the greater region. What color do y'all want? I heard somebody say blue. All right, blue it is. Okay, and we shade above the line. And so our darker region over there with that would be the solution. So 3 solutions. Give me a solution would be 1, 2, 3, 1, 2, 3. So I'm gonna say 3, 3. You all give me 2 more, and then give me 3 non-solutions. Yes, the work is getting less and less on my end. All right, so now you're gonna come over here. Actually, I'm gonna graph this one. X is less than 3. So people that have been paying attention to Mr. O'Neill know that X equal lines or X less than greater than lines are vertical lines. This is going to be a dashed line. If you need to pause the video to write down your solution, to do that. So less than 3, X is less than 3. Where are the X's less than 3? On which side? Well, they will be over here to the left. So I will get my shading out over here to the left. What color do I want? Let's pick orange. All right. Shade to the left of the line. That's less than 3. Make my shade look nice. You know what I'm saying? You know what I'm saying? All right, and then we have y is greater than x is x minus 2. So negative 2 is right here. Y is greater. Go up 1 over 1, up 1 over 1, up 1 over 1. So this line looks like this. And we have another dash line. Dash lines are popular in this season. Great for dash lines. And then this is greater than, so it's above the line. Wish I would extend this a little bit more so I could show you a little bit more. All right, so we are shading above the line. What color should I pick? Somebody said gray. Well, that's weird. All right, so shade above the line. So the darker region, y'all see the color coordination, all that good stuff, is where my solution lies. And then we pick two order pairs, well, three order pairs for solutions, three order pairs for not that are not solutions. And then we can always check the order pairs into the inequality statement and see if they work. If they work for both, then we know it's a solution. All right, you are doing these two on your own. Have fun with that, especially with this one. Get the y alone. Hint, hint. Don't forget what happens when we divide by a negative. All right. And then once you're done with that, you can move on to the next slide. And then we'll talk about this. Okay, so we have y is greater than or equal to x plus 2. And then y is less than or equal to x minus 3. So let's get to graphing. So at 2, and then we go up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1. So we have a solid line. I'm going to cheat. All right, so we have a solid line because it's equal to and we will shade above the line because it's greater than. So we shade above the line. It's a color we haven't picked yet. Let's pick brown. Shade above the line. All right, and then we have y-intercept is -3, and then we go up 1 over 1, up 1 over 1, 1 to the right, down 1 over 1, and then we have another solid line here. I just don't know why I just automatically picked this color to be black. I just don't get that. I keep changing the color. Why? Okay, so what do we know about the lines? All right, let's shade first. So let's pick another color. We'll pick light blue. This is less than, it's going to be below the line. So what do we see? The solution is where the two shaded regions intersect. So if we look at the solution, we see that the solution, there is no solution. You know why? Because the shaded regions do not intersect. And we know that when we have no solution with equations, we know that the slopes are the same. The slope here is 1. The slope here is 1. But it does not mean that we have, because the slopes are the same, that doesn't mean in an inequality that the solutions will be no solution. It'll be no solution if one is going up, shading up, and one is going down, which means they will never intersect because these lines never touch. So this is what no solution looks like. It looks like one has greater than and one has less than. But we'll see in a second that all of these will not be no solution. So look at the next one. So M is 1, B is 3, so go to 3. Put a dot here, up 1 over 1. We like slope to be 1, I guess so. So notice offhand, I already know that this is going to be, I'm just going to do my best. That's all I can do. That's all you can ask for. Do your best. We always automatically see that this is going to be parallel lines. But let's see what the solution is going to be. So this says y is less than, so I'm shading below the line. Right, this already looks a little different. Let's pick yellow again. So I'm shading below the line, right? Everything below the line and on the line will be a solution to this linear inequality. But when I look at y is -1, it's already in the region of the solution. So I can automatically conclude that this is not going to be a no solution problem, even though the lines are parallel. Up 1 over 1, up 1 over 1. Somebody's going to do his best. And where would I shade here? Well, I will shade above the line because it says y is greater than or equal to. Oh, I just noticed something. I made a mistake. There should be a dash line. Dash. dash, dash, dash. Maybe you caught it already, and you probably want to walk up to me, somebody like Rosie, and be like, oh, you made a mistake. Okay, so this is going to be greater than, so it's above the line. So look at where my solution is. My solution is in between the parallel lines. I would have extended that line. So here, the solution is in here. So any 3 points inside of these two parallel lines would be the solution. So write down 3 solutions, write down 3 non-solutions. And lastly, 1. I guess we can keep it red. Down 1 to the right 3. Down 1 to the right 3. Up 1. And then this is a solid line. Use my line tool because I got to stretch a long way. Look at that. Mr. O'Neil caught it beforehand, I should say. All right, so, and then this is greater than. So y is going to be greater. So I will shade greater, greater, greater above the line. Like that. And then when I graph the next line, we start at -2, go down 1 over 3. We know the lines are parallel. If these were equations, we will say, hey, no solution. But since we have to actually shade them, we can't say, hey, no solution. And I'll be like, hey, you're wrong. Do a little better dashes than that. And this says y is greater than, so it's going to be dash, and then I shade where? Above the line. Watch out now. I don't like that color. It doesn't really show that well. No. It's going to jack up our lives. I don't really like this either, but I'm tired of picking. So where's the solution? The solution is now here. So any point on the line or in this double shaded region. So what you're going to do, you're going to finish here. Please let it be known this is a 3. This one, that one, and you're done because we're not going to do group work. All right, have fun, people. Math is great. I almost forgot. What is wrong with me? It's been great. We out. See you next time.